Hi everyone, I'm Mahsa from Shah University of Technology, Iran. I will talk to you about a flexible Bayesian space-time model for dispersed data using PC priors. I joined work with my supervisor, Professor Bakishani. Apple is modeling data with non-negative integer values, which is the best model for them. Yeah, one of the most popular model is Poisson regression model. But when we encounter over dispersed or under dispersed data, is it still recommended? Oops, according to mean assumption of Poisson model, the equality of variance and mean in this situation, Poisson model is inefficient and leads to bias inference. Much research has been done on this problem and alternative models have been proposed such as generalized linear mixed model, finite mixture models, Hurdle model, and one of the alternative models which we focus on them is based on linear theory. Michelman 1995 proposed new distribution of cons by defining non-exponential distribution for waiting times. One of these new distribution is gamma can or GC model by assuming gamma distribution for waiting times. You can see the theoretical steps of this issue in the following links. We call YT has GC distribution with parameters alpha and gamma that its probability mass function is given by this, where Gn alpha YT is cumulative distribution function of gamma. As you know, it doesn't have closed form, so there is no closed form for GC distribution. True, however, this model has tempting features like modeling dispersed data. Alpha is a dispersion parameter that has a role to control and dispersion of data. When alpha is equal to 1, GC reduces to Poisson model and it's adequate for data with equivalent dispersion. And for alpha is greater than 1, GC model is convenient for under-dispersed data, and when our data is over-dispersed, we should consider value less than 1 for alpha. The mean of GC distribution is an infinite summation expression, so has no closed form. For this reason, we obtain a GC regression model based on waiting time variable to I. And then by using a relationship between waiting times and events, GC regression model can be written as this. Okay, now I wanna speak about the space-time GC regression model. Space-time GC regression model is defined as this, where eta st is equal to this expression such that x is quiet matrix, beta is regression coefficient, fs is space effect, ft is time effect, fst is space-time interaction effect, and est is an offset. Bayesian spatial and space-time models are often hierarchical. First level is related to observed data with likelihood function that I talked about them in previous slides. Now I want to speak about prior distributions and hyperprior parameters. A special effect. The special effect consists of a sum of two unstructured and structured effects. For unstructured effect, we consider normal distribution, and for structured effect, one of the choice is ICAR model as Bisek et al. Defined. Time effect, like space effect, we consider normal distribution for unstructured effect, and for structured effect, you can consider random walk 1, random walk 2, or even ICAR model. For space interaction effect, we consider four prior distribution types, and for speaking easily, I consider notation delta st for it. In type T, delta st is exchangeable and independently and identically distributed. In type 2, delta st is composed of spatially unstructured but temporally structured effects. Type 3 is opposite of type 2. Delta st is composed of spatially structured but temporally unstructured effects. Type 4 is made of both spatial and temporal structure effects. Now I want to speak about the prior of dispersion parameter alpha. We construct PC prior for it as Simpson et al. 2017 introduced it. Because of limitation of time, I speak rapidly and don't pay attention to details. Please, for more information, see my references. And now, please follow this theorem. Let GC distribution model distribution with parameters alpha and beta. When alpha is equal 1, the GC model reduces to Poisson, that is simple and non-distribution. So we define Bayes and flexible model based on waiting times distribution. Let gamma distribution with parameters alpha and beta is the flexible model, and gamma with parameters 1 and beta is the Bayes model. According to Simpson et al., the PC prior for alpha is given as follows. Here are likelihood function, priors for latent variables and parameters, and so corresponds posterior distribution. As you see, this equation is analytically interactable, especially when dimension of space and time are increased. In Bayesian paradigm, MCMC is much popular in this situation. But MCMC algorithms come with a wide range of problems such as convergence or computational time. To overcome the difficulties associated with MCMC, Rowe et al. 2009 introduced very fast and non-sampling based algorithm named integrated nested Laplace approximation, in abbreviation INLAP. This method combines Laplace approximation and numerical integration. INLAP gives answers in minutes and seconds, where MCMC requires hours and even days. For more details, see our INLAP website. To demonstrate the application of our purpose model, we perform a study on real data leukemia rate in Khorasan Razavi province, Iran during the years of 2012 to 2015. The location of Khorasan Razavi province in Iran is here. It has 16 cities. This figure shows the leukemia rate during the years of a study. Our considering model has the form this without covariate, but we consider space, time, and space-time interaction effect, and results confirm they are significant. EST is an offset that has this equation where NST is population of area, S in time, T. We fit three models GC, Poisson, and negative binomial to compare. This table shows that values of DIC and WIC criterion. We fit models with space-time interaction effect in 4 types, and models without space-time interaction effect and even without random effect. As you see, GC model in type 1 interaction effect has less value in both DIC and WAC criterion, so this model is more preferable. Here, estimated structured and unstructured time effects are shown. As you see, all models follow the main pattern of data. This table shows the estimation of parameters. The estimation of dispersion parameter alpha is near 1. So Poisson and GC models are expected to have similar performance, although results confirm this. And the results related to negative binomial are far from the alternative models. And here shows the posterior mean of space-time interaction effect for GC in first row and Poisson in second row. The existence of space-time is clear in this map. For example, cities in the southeast of the province are at lower risk in 2012 if risk for them in 2015 is increased, and other cities can also be described. In conclusion, at first we present new space-time flexible counter regression model called GC, which is appropriate for dispersed data, and then we construct PC prior for dispersion parameter, and finally we do steady and real data that results show the performance of our proposed model. Here you can find some main references. Thank you. Please contact others with these emails. Have a nice time. Keep the coronavirus away from you. Bye bye.